Greetings, math person. Don't be afraid to learn from your mistakes. And speaking of mistakes, this problem has something missing that makes it impossible to absolutely solve. So I chose a nice round number of 20 miles to represent this trip to town A. Now, we're going to use a common math formula that relates the distance, rate, and time, and rate can be interchanged with speed. So, for example, if we are going to go 60 miles an hour for 2 hours, 60 times 2 is 120 miles that we would travel. Or if we were going to go 60 miles an hour for 5 hours, 60 times 5 would be 300 miles that we would travel. We're going to make two equations, one for the upstream trip and one for the downstream trip. And I've decided to represent the upstream rate as U and the downstream rate as D. For the upstream equation, we went the 20 miles and it took 2 hours. And with this equation, all we need to do is divide both sides by 2 and find out that our upstream rate or speed is 10 miles per hour. For the second equation, it's a little more complicated because our time is given in hours and minutes. To make this thing work, we need our time to be all in one type of unit. In this case, it's best to have it hours so we can get miles per hour. So 40 minutes is 2/3 of an hour because 20 minutes is 1/3 of an hour. So 1 2/3 hours. This 5/3 is representing the mixed number 1 2/3. So 5/3 is the same as 1 2/3. Now, once we have that equation, distance, rate, and time, what we can do to solve this is start by multiplying both sides by 3, since we're dividing by 3 on that side. And this becomes 60 equals 5D. And then we can divide both sides by 5, and we get 12 equals D. So the rate of the boat in still water should be the average of the speed going upstream and the speed going downstream. So our upstream speed was 10, our downstream speed was 12, and so 22 divided by 2 is 11. So the speed of the boat in still water is 11. Now, I have another strategy that gets the same solution, but let me just tell you about that. We have our same information, except in this one, we're going to talk about the rate being the boat's rate in an upstream minus the current, because the current is pushing against the boat going upstream. And for going downstream, we're going to call it the boat's rate plus the current, because the current is pushing us downstream. Now, we're going to simplify these a little bit, or at least change their appearance by multiplying by 2, using the distributive property, and on this one, multiplying by 5/3 using the distributive property. That gives us the two equations down here, 2b minus 2c equals 20, and 5/3 b plus 5/3 c equals 20. Now, we're angling toward the elimination method, which means we're going to try to eliminate one of these two variables so we can just concentrate on one. In this case, we want to concentrate on b. So it would be very nice if we could do something to change these two coefficients of 5/3 into also 2s, like they are in the upstream equation. So if we multiply by 1.2, then 1.2 times 5/3 becomes 2b. 1.2 times 5/3 c becomes 2c. And so now we have two equations which, when we add them together, will eliminate c, because it's negative 2c plus positive 2c, which is nothing. And then we're going to add the column of b's, which has 4b. 2b plus 2b is 4b. And 20 plus 24 is 44. So then we can simply divide by 4 and get our b, or boat speed, equaling 11, just like we got before. I should mention that don't forget in this method to multiply the 1.2 times the 20 also to get the 24. Thanks for watching. And remember that the study of math is looking for patterns and describing them so that you can use them to your advantage. Bye now.